An electrical metallic tubing, or EMT, grounding bushing is the fitting often employed to bond an EMT conduit to a ground wire. These bushings are typically constructed from brass to ensure durability and good conductivity. They feature a lug that allows for the connection of a ground wire and are available in trade sizes ranging from 1/2 inch to 1 and 1/4 inches to accommodate various conduit sizes. Installation of an EMT grounding bushing involves several steps. Firstly, cut the EMT conduit to the desired length. Secondly, thread the grounding bushing onto the end of the conduit. Thirdly, strip the end of the ground wire and loop it around the lug on the bushing. Fourthly, tighten the set screw to secure the ground wire. Fifthly, if the conduit run is longer than 20 feet, bond the conduit to the ground rod at both ends using additional grounding bushings and wire. Several manufacturers produce EMT grounding bushings, including Appleton Electric, Cooper B Line, and OZ Gedney. Appleton Electric offers the for example B1212 model, Cooper B Line produces the for example B12, and OZ Gedney manufactures the 6985 model. These bushings are designed to provide a reliable and safe method for grounding EMT conduit systems. When selecting an EMT grounding bushing, consider factors such as the size of the conduit, the size of the ground wire, and the specific requirements of the electrical installation. Ensure that the bushing is dual listed to meet safety standards. Proper grounding is essential for electrical safety, and EMT grounding bushings play a crucial role in ensuring that electrical systems are properly grounded. By following the installation steps and selecting the appropriate bushing, electricians can create safe and reliable electrical installations. Remember to always consult with a qualified electrician for any electrical work. The purpose of grounding is to provide a low impedance path for fault current to return to the source, thereby tripping the overcurrent protective device such as a circuit breaker or fuse, and energizing the circuit. This prevents electrical shock hazards and minimizes the risk of fire. Grounding also helps to stabilize voltage levels in the electrical system, reducing electrical noise and improving the performance of sensitive electronic equipment. When connecting a ground wire to structural steel or rebar in a commercial building, it's important to adhere to the National Electrical Code, or NEC, requirements for grounding and bonding. The NEC specifies the minimum size of the grounding electrode conductor, which is the wire that connects the grounding electrode, such as a ground rod or structural steel, to the electrical system's grounding point. The size of the grounding electrode conductor is based on the size of the service entrance conductors. For example, according to NEC Table 250.66, if the service entrance conductors are 3/0 copper, the minimum size of the grounding electrode conductor is number 4 copper. However, local codes or project specifications may require a larger grounding electrode conductor. In addition to the grounding electrode conductor, it's also important to bond the metal conduit to the structural steel or rebar. Bonding ensures that all metal parts of the electrical system are electrically connected, creating a low impedance path for fault current. This helps to prevent voltage differences between metal parts, which can create a shock hazard. The NEC requires that metal conduit be bonded to the grounding electrode at both ends if the conduit run is longer than 20 feet. This can be accomplished using EMT grounding bushings and bonding jumpers. A bonding jumper is a short length of wire that connects the conduit to the structural steel or rebar. The size of the bonding jumper is based on the size of the grounding electrode conductor. For example, according to NEC Table 250.102 Kern, if the grounding electrode conductor is number 4 copper, the minimum size of the bonding jumper is number 8 copper. When installing EMT grounding bushings and bonding jumpers, ensure that all connections are tight and secure. Use appropriate tools and techniques to avoid damaging the conduit or the conductors. Inspect all connections after installation to verify that they are properly made. In summary, grounding and bonding are essential for electrical safety in commercial buildings. By following the NEC requirements and using appropriate grounding and bonding methods, electricians can create safe and reliable electrical systems. When dealing with electrical systems, it is always important to prioritize safety. Here are some key safety precautions to keep in mind. Firstly, always energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Thirdly, follow all applicable electrical codes and standards. Fourthly, never work on electrical systems when you are tired or distracted. Fifthly, if you are not comfortable working on electrical systems, hire a qualified electrician. Sixthly, always double-check your work to ensure that all connections are tight and secure. Seventhly, after completing the work, thoroughly inspect the system to verify that it is safe to energize. Eighthly, properly label all circuits and equipment for easy identification. Ninthly, maintain a clean and organized work area to prevent accidents. Tenthly, be aware of your surroundings and potential hazards. Electrical safety is everyone's responsibility. By following these safety precautions, you can help prevent electrical shocks, fires, and other accidents. The purpose of an EMT grounding bushing is to provide a secure and reliable connection between the electrical metallic tubing and the grounding system. This connection ensures that any fault current flowing through the conduit will be safely directed to ground, preventing electrical shock hazards and minimizing the risk of fire. The grounding bushing is typically made of brass or aluminum, both of which are excellent conductors of electricity. The bushing is designed to fit snugly onto the end of the conduit, providing a low impedance path for fault current. The bushing also includes a lug or set screw for connecting a ground wire. This ground wire is typically connected to the building's grounding electrode system, which may include ground rods, water pipes, or structural steel. The size of the grounding bushing and the ground wire must be appropriate for the size of the conduit and the ampacity of the circuit. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure that electrical systems are safe and reliable. When installing EMT grounding bushings, it is important to follow the manufacturer's instructions and all applicable electrical codes. This will help to ensure that the grounding system is properly installed and will provide adequate protection against electrical shock hazards. Proper grounding is essential for the safe operation of electrical systems. By using EMT grounding bushings and following the NEC requirements, electricians can help to ensure that electrical systems are properly grounded and that people and property are protected from electrical hazards. Remember to always consult with a qualified electrician for any electrical work. It is crucial to select the correct size of the EMT grounding bushing for the conduit being used. Bushings are available in various trade sizes, typically ranging from 1/2 inch to 1 and 1/4 inches. Using the wrong size bushing can compromise the integrity of the grounding connection and potentially create a safety hazard. When installing the grounding bushing, ensure that it is securely tightened onto the conduit. A loose bushing can create a high resistance connection, which can impede the flow of fault current. Use appropriate tools to tighten the bushing to the manufacturer's recommended torque. The grounding wire connected to the bushing should be properly sized for the circuit it is serving. The NEC provides guidelines for determining the appropriate size of the grounding wire based on the ampacity of the circuit. Using an undersized grounding wire can limit the amount of fault current that can safely flow to ground, potentially delaying the tripping of the overcurrent protective device. Inspect the grounding bushing and the ground wire periodically to ensure that they are in good condition. Look for signs of corrosion, damage, or loose connections. Replace any damaged or corroded components immediately to maintain the integrity of the grounding system. When working with electrical systems, always prioritize safety. To energize the circuit before working on it, wear appropriate personal protective equipment, and follow all applicable electrical codes and standards. If you are not comfortable working on electrical systems, hire a qualified electrician. In addition to providing a grounding path for fault current, EMT grounding bushings can also help to reduce electromagnetic interference, or EMI. EMI is a type of electrical noise that can disrupt the operation of sensitive electronic equipment. By providing a low impedance path for ground current, grounding bushings can help to minimize EMI and improve the performance of electronic equipment. Some EMT grounding bushings are designed with special features to further reduce EMI. These bushings may include a built-in filter or shield that blocks EMI from entering the conduit. When selecting grounding bushings for applications where EMI is a concern, consider using bushings with these special features. The effectiveness of the grounding system depends on the quality of the connections between the various components. Ensure that all connections are clean, tight, and corrosion-free. Use appropriate connectors and tools to make the connections and follow the manufacturer's instructions. Periodic inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Inspect all connections, components, and conductors for signs of damage, corrosion, or deterioration. Replace any damaged or corroded components immediately. Test the grounding system periodically to verify that it is functioning properly. Use a ground resistance tester to measure the resistance of the grounding system. The resistance should be low enough to allow fault current to flow safely to ground. In some cases, it may be necessary to use multiple grounding electrodes to achieve the desired ground resistance. The NEC provides guidelines for the installation of multiple grounding electrodes. When using multiple grounding electrodes, ensure that they are properly bonded together. This will help to ensure that all electrodes are equally effective in providing a grounding path. The location of the grounding electrodes can also affect the effectiveness of the grounding system. Grounding electrodes should be located in areas where the soil is moist and conductive. Avoid locating grounding electrodes in dry or sandy areas. The depth of the grounding electrodes can also affect the effectiveness of the grounding system. Grounding electrodes should be driven deep enough into the ground to reach moist soil. The NEC provides guidelines for the depth of grounding electrodes. In addition to grounding electrodes, the building's structural steel can also be used as a grounding electrode. The NEC allows the use of structural steel as a grounding electrode if it meets certain requirements. When using structural steel as a grounding electrode, ensure that it is properly bonded to the electrical system. In some cases, it may be necessary to supplement the structural steel grounding electrode with additional grounding electrodes. The purpose of bonding is to create a low impedance path for fault current to flow back to the source. This helps to ensure that the overcurrent protective device will trip quickly and safely. Bonding also helps to equalize the voltage potential between different metal parts of the electrical system. This reduces the risk of electrical shock. The NEC provides detailed requirements for bonding electrical systems. These requirements are designed to ensure that electrical systems are safe and reliable. When bonding metal conduit, it is important to use appropriate bonding connectors and techniques. The bonding connector should be listed for use with the type of conduit being used. The bonding connection should be clean, tight, and corrosion-free. When bonding metal enclosures, it is important to use appropriate bonding jumpers. The bonding jumpers should be sized according to the NEC requirements. The bonding jumpers should be connected to the metal enclosures in a way that provides a low impedance path for fault current. When bonding different types of metal together, it is important to use compatible metals. Using incompatible metals can lead to corrosion and a loss of bonding integrity. In some cases, it may be necessary to use a special bonding compound to prevent corrosion. The NEC requires that all electrical equipment be properly labeled. The labels should identify the equipment, its voltage, and its ampacity. The labels should be legible and durable. The labels should be placed in a location where they can be easily seen. Proper labeling is essential for the safe operation and maintenance of electrical equipment. It helps to prevent mistakes and ensures that the equipment is used correctly. In addition to labeling, it is also important to keep electrical equipment clean and free of debris. Dust, dirt, and moisture can damage electrical equipment and create a fire hazard. Electrical equipment should be inspected regularly for signs of damage or deterioration. Any damaged or deteriorated equipment should be repaired or replaced immediately. Regular maintenance is essential for the safe and reliable operation of electrical equipment. It helps to prevent breakdowns and extends the life of the equipment. The NEC provides detailed requirements for the installation, maintenance, and operation of electrical systems. It is important to be familiar with these requirements and to follow them carefully. The NEC is updated every 3 years. It is important to stay up to date with the latest version of the NEC. The NEC is a valuable resource for electricians, engineers, and other professionals who work with electrical systems. It provides the information they need to design, install, and maintain safe and reliable electrical systems. Electrical safety is everyone's responsibility. By following the NEC requirements and taking appropriate safety precautions, we can help to prevent electrical shocks, fires, and other accidents. Remember to always consult with a qualified electrician for any electrical work.